So today I'm going to dive into a bit more on the indicators that we use. All of these are probably not going to be important to each of you in your respective jobs, but maybe you can get something out of it. Some of these tools will be something that you will be able to use. And I'm also going to talk a little bit about the US Drought Monitor's website and some of the tools that are available through that as well. So if you haven't seen the Drought Monitor website, this is diving in from off the home page, and some of the things that are available. The map's always released on Thursday morning, and if you go into the maps section, you're able to get a whole bunch of different things from there. You can compare 2 different weeks. You can look at, go into the map archive, change maps, animations, so you can look at drought developing over a specific time period. We've seen a number of people use the time series. You've probably seen those, and those date back to 2000 when the Drought Monitor started. Data tables, you can download the shapefiles. So we've seen a couple of the people giving presentations that have used these. The nice thing about the time series, you can do the time series in a variety of different spatial measures. So you can do it by climate divisions, you can do it by state, county, hydrologic units, etc. You can also pull the data tables for the individual week. So these are calculations that are made in GIS, looking at the percentages of a particular drought category. And so, for example, the first one, you can look at the current week is on the top, and the percentage of the particular area, like the US, is 1.59% in abnormally dry conditions. You could break it down and look at population that's impacted by a particular category. As I mentioned, we have the, for those of you who are GIS people and you want the data yourself to be able to overlay, something from your respective agencies that may be important, you can download the shape files and other types of file formats that are available. And then we have the change maps, which update every single week as a new map comes out. This, for example, on the left-hand side is looking at the, it's comparing the last week's map to the start of the water year. So that's how many category changes that have occurred since then, comparing the two. So you can obviously see the warmer colors in the southwest, where we've had all the drought development, and up in the northern Rockies and Pacific Northwest, where we've had improvement in conditions since the beginning of the water year. You can also make these change maps by a variety of different spatial measures as well. On the bottom right there, you've got the upper Colorado River Basin. So as we talked about yesterday, these are some of the key indicators that we're using in our drought monitoring assessment. These are things, probably some of these your respective agencies are using as well in your work. And I'm going to go into a bit more detail as to each one of these. Again, our convergence of evidence approach and how we integrate all these different indicators to make the weekly map. So first, looking at some of the meteorological and climatological data, we use the National Weather Service AHAP's precipitation analysis data, and that's updated. I think it updates every hour. And again, this is a mix of radar data and observational data, and satellite estimates, precipitation estimates for areas where there's not radar coverage. You can download geotiffs and pull them into GIS if you wanted to look at that data, but you can also look at it in a variety of different time frames, which is nice, starting with the current day and going back. I think it goes back to the beginning of the calendar year and then water year as well. And you can look at things like this, for example, was the observed precipitation for the particular day. This was a couple days ago. Once you get into the historical data, 7-day, 14, 30-day, etc., then you can get the precipitation amounts. You can get departures from normal for that time period. You can also get percentage of normal as well. And just a quick note on the AHAPS data, as I mentioned yesterday, there's using it in the western US, you kind of have to use caution with some of the data because of the radar gaps that we have in the western US. So for the western US, we like to use a lot of the AIS climate data, and AIS is the data set that's used by the regional climate centers. And that data comes out of my office at the Western Regional Climate Center as well as the High Plains Climate Center. Each of our offices do something a little bit different with the AIS data. The data is updated daily. Precipitation, these are some of the different parameters, percentage of normal, departures, observed, temperature, we have SPI. And this is an example of one of the products that comes out of our office at the Western Regional Climate Center. These are state AIS maps, and I think these could be really useful. I don't know if many of you are aware of these particular maps. So these are updated on a daily basis. So you can go to, when you go to this web page, it'll come, it's got a map of the Western US, and there'll be I kind of cut it off when I did did the screenshot, but you can pick the state of interest. So this one I obviously chose Utah, and you can go through and you can see on the top of the page there's a whole bunch of different parameters you can look at and time scales, and all of these maps, there's hundreds of them, they update. It's an automated process. They update every single day. So you can look at, for example, I've got here, this is total precipitation. You pick your time scale. This particular one was looking at the 30-day precip in the state. Gives you the scale. Obviously, there's interpolation that goes on in creating these. If you click on the little asterisk on it, it'll give you the actual observing points for all the stations. So those are the actual station data and the locations of the stations. So you can see you've got some pretty large gaps in data around the state. And these are just a couple more of the examples of some of the products, percentage of average precipitation. That's looking at the last month. On the left-hand side, you can see it's been pretty dry. June's normally pretty dry. And you can see a couple areas that got some storms in the southern half of the state. Temperature departures from average for that time period. Obviously been warm as it's been across the western US. Another product you can get from AIS is individual station data. So what you're looking at here on the left-hand side, this is from the Cedar City Airport. And so what you have is basically the blue lines that are going up and down. That's basically, since I think I had chosen, that's from the beginning of the water year, October 1st. So you can see each line represents the high and the low for that particular day. And then you have these are the normals within the brown area. So that's the average. for that time period over the entire period of record. And then you have the extreme highs and lows. So you can get a quick look as to how the past water years looked at in terms of temperature. On the right side is looking at precipitation, and there's some different options in creating these maps, but if you look at this, you'll see the 2008 precip since the beginning of the calendar year is in green. And if you look at the normals, that's the brown line. That's the average over the long term, the period of record of the station. So you can see we're below normal. You can click on the highest and the lowest precip in the period of record, so you can get some sort of context as to the range of values that you've seen at that station over the period of record. And you can see it's been much lower, this back in 2002, 2005 for the high. Some other data that we use, I don't know if you're familiar with the RAWS network. That is the interagency fire weather network that's used by the BLM, National Park Service, U.S. Fish and Wildlife Service. And that probably has the best spatial coverage of meteorological stations in the western U.S. The network started in the 1980s. And it's now almost long enough that we're able to develop some climatologies from those stations. The nice thing about those stations as compared to other observing networks, like Co-op Network and some other ones, airport networks, ASOS, most of these stations are kind of in foothill locations. So it gives you a little different look as opposed to a lot of the other stations or where urban areas are in valleys. This will give you a look in kind of that mid-range of elevations, and there's about 2,000 of them across the western U.S. For drought monitoring, for us, it's difficult to use a lot of the data from these stations because we like to use percentage rankings, and a lot of these don't have climatologies developed for them. But I use them during monsoon season to be able to get a good idea because monsoon is so spotty. It gives you some nice estimates as to where the rain is falling and how much. And those are the parameters that are measured at those stations. Another product that we use for the West that comes out of our office as well at the Western Regional Climate Center is the West-Wide Drought Tracker. And this data and the data products are based on PRISM data. So PRISM is a gridded data set there's 2 resolutions, 4 kilometer and 800 meter. And this is out of Oregon State University. And it's also the official climatological data set of the USDA. It's a widely accepted and used data set in research and in the government. And it does a really good job at handling complex terrain in terms of the interpolation scheme. It has a very complex interpolation scheme that does a really good job for the mountain areas in the western U.S. So this is our really good data product for the western U.S. And some of the things that we produce with it are PDSI, Palmer, SPI, SPEI, and temperature and precip anomaly maps. You can also create individual time series from the data set. So we have an interactive map on it, and you can select whether you want to, you could pick a particular pixel, because this is gridded data. This is 4 kilometer gridded data. So if you picked a pixel over Salt Lake City, or you could do it by hydrologic unit, county, or you can do it statewide. For example, on the right side, that's a temperature map, or a temperature time series, and that is for Salt Lake County. And this goes back, PRISM has integrated data from the US Co-op network, which is basically the climatological, it's a cooperative observer network for the National Weather Service. And this data dates back to the late 1800s. Basically, it's the observational record. And as you can see, and you can put in a time period in which you're producing averages. I did a 10-year average. That's what the black line is on it. So you can see the pattern over the last 120 plus years with the warming that's gone on over, particularly over the last 10 years. On the left side, same thing I did for Salt Lake County. That's precipitation, and you can see the high degree of temporal variability in this area, which is pretty typical around the West. Snowpack, most of you guys are probably familiar with the SNOWTEL network and some of the data products. Those are on the right, and that's snow water equivalent data, percentage of normal. This is looking back right before the April 1st, the important April 1st time frame when streamflow forecasts are made and they figure out how much water is going to be flowing into the reservoirs. We're going to lose some of the, it looks like NRCS is going to cut a number of their products, which is really disappointing because of some funding issues. So some of these maps are going to be going away, which is really unfortunate. But I think we're going to try and reproduce some of these through our center. And on the bottom left, this is another source for snow data. This is modeled data from the National Operational Hydrologic, I forgot the whole acronym. It's snow related, basically. It's out of Minnesota, and this is modeled and satellite data, but it provides good estimates on snow cover and other snow-related parameters like snow water equivalency. Most of you are familiar with the USGS stream flows, and for drought monitoring purposes, we kind of look at all these different time frames from current 7-day out to 28-day. We like to look at longer term what's going on with a particular flow, but during wintertime and we'll have storm events, and we like to see the current and 7-day to see how, if it's just you see a stream flow response, it's just a spike, or is it something that's, you're going to see something that the stream flows really pick up more, and that's usually an indicator of the soil moisture is pretty saturated. Soil moisture is a really difficult parameter to figure out what's going on. A lot of the different models out there tell us different things, and so the ones that we use for our monitoring purposes, we use the CPC data, which is on the top, and also NLDAS, and this is an Ensemble, so that integrates 4 different models, and that takes an average of those 4 models, and that data is available to be able to put into like GeoTIFFs, so you can pull those into GIS as well. We also get soil moisture data from the USDA. This is much more, the products that come out are pretty coarse, but these are from private observers that the USDA has that report in data every month, but this helps us get a good idea statewide of what the data is looking like. Sometimes this data soil moisture data can be kind of tricky to work with, and I mean, as you can see, this is topsoil moisture, short to very short, and Arizona really stands out to me because it's been really dry there, but perhaps the monsoon has helped, and maybe some of those areas where the observers are in irrigated areas. I like to if I have some question about the model data, I try to look at some of the in situ on the ground measurements, and fortunately, and this is from the NRCS SCAN network, and this is their national soil monitoring network. And as you can see, you're very fortunate in Utah to have probably the best spatial density of scan stations in the whole network, and there's been more of them going out. That's a picture of a scan site on the upper right, and right below that is looking at some of the data that comes from it. That's looking at soil moisture that's a profile of soil moisture looking at 5 different depths of moisture. And it's nice to look at that so you can kind of verify if I see something that really stands out on one of the other data products from CPC or NLDAS. I'll take a look if there is a scan site around there. I'll take a look at that and see if a particular rain event or snow has impacted, just the surface layers, or is it getting down into kind of the root zone? And then we use these objective blends. These are available through NOAA Climate Prediction Center, and these are an experimental product that we use quite a bit at the Drought Monitor. I think they're really useful, particularly looking at, I'll show you, there's a couple different ones, but looking at short-term conditions and long-term conditions. And these integrate, these are based on climate division data, and they integrate a variety of other things like Palmer and the Palmer Z index, soil moisture, and precipitation at different scales. And the L's and the S's and the dash on the map are representing whether predominantly you're seeing short-term or long-term, which one of those dominates between the two of them, of the worst conditions, and the dash is both short-term and long-term. So these type of maps all come out weekly. That's short-term on the left and long-term on the right, and you can see a lot of 0 to 2 percentile D4 in Utah right now. And those are the configurations on the bottom left of the data that goes in to produce those. Some more things coming out of CPC that we use. These are the drought outlooks. So the Drought Monitor is current conditions, but CPC also makes forecasts as to what they think is going to happen with the drought conditions. So on the left-hand side, you've got the monthly outlook, and you can see that the southern part of Utah and central is going to remain in drought, but some improvement, and it's supposed to get worse in the northern sections. On the right-hand side is a seasonal forecast, so that goes out a little further in time, several months. CPC, probably most of you have seen these. There's some more forecast products that we use. On the left-hand side, these are short-term. That's looking at 7-day quantitative precipitation forecasts for the continental U.S. And then some other ones, they have a 6 to 10-day precipitation. That is precipitation, but they also do a temperature outlook as well. So they have a 6 to 10 day, 8 to 14 day, and then they do a monthly and a seasonal outlook as well. And the areas in the green are areas that there's a higher probability of above average precipitation in those areas, and the brown areas are below normal probability of precipitation. As opposed to the outlooks, a lot of people use the CPC seasonal outlooks. You see them all the time in the news and other things. I like the NMME product that doesn't get as much attention, but I really like that one because this is another ensemble. So basically, on the left-hand side, you can see that that's the ensemble. And these are all the different models. These are the big ones from around the world that go into that particular model. And the Ensemble is an average of all of those. And then, as Elizabeth mentioned, this is another product that's generated out of our office at Western Regional Climate Center, as well as the University of Idaho. And you can take a look at the data sets. Basically, it's a Google map, and that you can click on different parameters and zoom in and out on it and look at things like Landsat and NIDIS. So you can take a look at things like NDVI, which is looking at kind of greenness of, so looking at vegetation. You can look at snowpack. The neat thing about this is Landsat in the past, there's a lot of data, and if you want to be able to make look at something like departures from normal over the period of record, it takes a lot of calculations, a lot of computing power, but the strength of Climate Engine is it uses the Google Cloud, so you can make these calculations on the fly, and it sends it out to the cloud, and within a minute, you're able to, be able to make, look at a bunch of Landsat data. Essentially, it's pretty neat. Where it used to take a lot of time and energy to create those type of maps, so it's a really powerful tool. And then it has GridMet, which is similar to Prism data, and like our West-Wide Drought Tracker. And then it has SNODAS data. As well for looking at estimates of snow cover and SWE, which is what I had mentioned previously from the National Weather Service, but this allows you to look at it in an interactive map. This is kind of an example. There's a screenshot of some of, this is looking at Landsat data. And using this particular product, you can choose remote sensing, which is Landsat, and the product, the variable, this is NDVI, and this is percent difference from average. You can choose whatever time frame you want to look at. You just press the button. And this particular area, this is looking at Lovelock, Nevada, which is in north central Nevada. And it's a small agricultural community. And we were in drought a few years ago, and we wanted to get some sort of idea as to how it's impacting, because they had their allotments cut back. So this is looking at, that's looking at Landsat data and looking at the average greenness. So you can see how many fields were fallow during that time period. So we can get a good idea of kind of the estimates as how it's, the spatial area and how it's affecting those communities. And this is another example of that. This is from the California drought. This is in the southern San Joaquin Valley in California, Central Valley. Same idea. You've got tons of farms across the whole Central Valley, and we're trying to get an idea of where it's impacting it. And then using Landsat data, which goes back to the 1970s. So you're taking an average greenness for a particular time period, comparing it to whatever time period you select in the present day, and you can see on the you can see all the red area, or the orange is, those are fields that are fallow. And they've used these to be able to make estimates as to acreage and losses from agriculture in these areas. And as Elizabeth mentioned, it's another product coming out of our office, as well as from Boulder, from NOAA. This is evaporative demand drought index. And you can look at evaporative demand at a variety of different time scales. This is updated daily as well. Another tool for looking at short-term, this flash drought we've spoken about a little bit. National Drought Mitigation Center has created this product called QuickDry, and it looks at some different short-term parameters, and so you can get an idea of what's going on in the short term and how it's impacting the vegetation in certain areas. And you can see again Utah with a lot of orange, excuse me. And then here's another
And these are both satellite-based products with some climate data that's added to it as well. And this is QuickDry, and this is the same thing. It comes out every week and looks at greenness components as well as different climatic variables. We also use the, in terms of looking at impacts, we use these crop progress reports from NAS that come out, and they kind of vary how much detail and how consistent the information comes out, but these are really valuable to us as well. And we also get impacts information from the National Drought Mitigation Center, the Drought Impact Reporter, which basically they have basically written scripts to go out and search for anything with the word Utah in it and drought and things like that. So it catalogs newspaper articles, any sort of drought impacts that are even from farmers and et cetera that are reported to them, and you can basically click on a county. It tells you how many impacts have been reported in a particular county. You click on that, it'll actually send you to a URL to the actual article. And then just kind of wrapping things up, some of the drought monitoring challenges in Utah that we have, and these are pretty much somewhat across the board in the western U.S. They're not particular to Utah, but just drought monitoring is difficult because of the high degree of spatial and temporal variability in climate, and that's mainly related to a couple things. That's related to, obviously you've got a lot of mountains in the state and complex terrain, so you see a lot of variability between windward and leeward sides of ranges. Also the low spatial density of the observing stations. You've got big gaps around the state that could definitely, we could be nice to see some more stations out there. And as Seth and others mentioned, just kind of some of the challenges, and we need to improve our networks and getting drought impacts information from around the states. And that would be really helpful for us to be able to get a better idea of how drought is impacting your various ag communities around the state. That's about it. Thank you.